All right, so we're going to move on with transitivity, but one thing we're thinking about completeness is it kind of does seem sort of obvious, but for group decisions, for instance, it may not be. It may be a lot less obvious. Um, so, for instance, you might have heard of the principle of Pareto efficiency or Pareto optimality, where a decision is Pareto preferred if it makes everyone better than another outcome. And a choice is Pareto optimal if I think about this as, let's say, the happiness of one person and the happiness of another person, or you could also say their preferences. It's Pareto optimal if there's no way I can make one person better off without making someone else worse off. Right? But that is not a complete relation, because the Pareto criterion does not tell me whether this point is any better than this point is any better than this point. So particularly when we talk about social welfare functions, the distinction between complete and non-complete may matter, and the implications of that. Okay, then the next property I wanted to cover was transitivity, which maybe also seems obvious. But we can discuss whether people actually show violations of this in real-world data, in experiments, in survey data. And what it would mean. I mean, that's a longer discussion, is how could we show transitivity? Did I put enough bits in here? Transitivity. I was worried I put too many IT pairings there. I may need to get a bite to eat here. Okay. So, transitivity, let's give the formal definition of the transitivity of a relation. Okay, a binary relation. Okay, the definition of a binary relation is, I believe it's just a relationship between two objects where you can either say this holds or this doesn't hold. A binary relation R on the set X, so considering, perhaps the set of all real numbers, or perhaps the set of all choices among all combinations of goods in the world. Think about different, sets we could be looking at. Set of all positive numbers. Binary relation on the set X is transitive if for any members, okay, now we need at least three elements to talk about this, okay? For all, this means for all or for any, X, Y, and Z, with all within X, where X, Y, and Z are all within the set X, for which X relates to Y and Y relates to Z, we have X relates to Z. Okay. So if X relates to Y, is preferred to Y, and Y relates to Z, Y is preferred to Z, then we have, so this means if this, then this, then we have X relates to Z. Or in this particular case, if X is preferred, or at least as good, I should say, this will also hold for strict preference, as can be, as a consequence of this, as can be proven. If X is strictly preferred to Y, and Y is strictly preferred to Z, then weakly preferred to Z, also strictly preferred, but I'm stating it in terms of the primal thing here, then X is weakly preferred to Z. This is the condition known as transitivity. Okay? I can't prove transitivity holds from other conditions. No, this is an assumption. Okay? Now, certain preference relations, for certain preference relations, you could easily show that it has transitivity. And that's what much of the chapter goes into. For instance, if the preference relation simply assigns a number to each option, we might call that a value function. You might be familiar with a utility function. And if the person's preference relation is X, so suppose options are given by numbers, suppose the preference relation is X is preferred, weakly preferred to Y, if the numeric representation of X, whatever that is, let's call it V, value function of X, is greater than V of Y, where V maps from something to a real number. V maps from some combination to a real number. This here is clearly, we can clearly show that it's transitive, right? Because, I could say, well, if, let's put some space here. If x is weakly preferred to y, then that means that v of x is greater than v of y, and if y is weakly preferred to z by this particular preference relation, so that's the old school chalk, then we know that v of y is greater than v of z, greater than or equal to, and we know that if v of x is greater than or equal to v of y, and v of y is greater than or equal to v of z, then we have v of x is greater than or equal to v of z by the property of the greater than or equal to relationship. So then we know, I'm just being complete here, that v of x is weakly preferred to we know that if v of x is greater than or equal to v of z, then by this preference relation, x is weakly preferred to z. So I've then showed transitivity, right? This is the definition of transitivity for a preference relation. And obviously, I could extend it to any chain of elements. Okay, so that's a transitive binary relation. That's a transitive relations. That's a transitive relations. It extends, as you see in the notes, to strict preferences. It will also extend to indifference. The transitivity will extend to the indifference. I probably should have kept that up on the board. It can extend to chains combining indifference and preferences. So for instance, we'll see that if none of this seems anything other than obvious, I accept that. If A is strictly preferred to B and B is at least as good as C, well then it seems intuitive and you could prove that A will be strictly preferred to C if transitivity holds. Okay? All right, so why should we expect this to hold? Why is this a reasonable axiom? So I said, what choices will people make? How can we model people's choices in a way that is, are you familiar with this notation that, well, maybe I'm misusing this, but let me skip the WLOG now, because that's a little bit different. That's more of a mathematical thing. Okay, but what are some, assumptions we can make, some axioms over people's preferences? And then once we get into the world of choice, we could say if people are choosing according to these preferences, we may have predictions for behavior. Right? And what are some fairly non-controversial ones? Can you argue against these? We talked about completeness. We could also talk about transitivity. What is a reason to think that our preferences should obey transitivity? Do you have any thoughts on that?
If they didn't obey transitivity, it would be very hard to come to any, or well, to
make decisions?
Yeah, just the whole way.
So if my preferences didn't obey transitivity, then it might be that if I was presented a bundle of options, that's a good point. So suppose that in violation of transitivity, and I'll just because it's easiest to discuss, I will talk about a violation of transitivity with respect to strict preferences. Okay, so suppose that A was strictly preferred to B, B was strictly preferred to C, apples preferred to bananas, bananas preferred to cherries, and C strictly preferred to A. Okay? So then if you presented someone with a choice between apples and bananas and cherries, if you want apples, bananas, or cherries, you're right. They would have a hard time making such a choice because if they would weigh each option side by side, it would depend on the order that they weighed the options. That's nice. I like that insight. And so if they did it once, they might say, okay, apples prefer to banana, so I'll stick with apple. Cherries prefer to apple, so I'll go with cherry. But then they might try to test their preferences and say, okay, what about banana versus cherry? Oh, shoot, I prefer banana. Now I'm flummoxed. Certainly, you can imagine this apply. In fact, there's a classic case when we start talking about social preferences. In fact, there's particular reasonable seeming setups where it seems like transitivity fails to hold. This gets to, I think, Arrow's impossibility theorem of social choice. But with individual choice, transitivity seems fairly reasonable to me. But there are experiments where people seem to be violating transitivity, where people are, and I think if you do the, if you look at the Osborne-Rubinstein reading, they gave a survey where they asked people to make lots of different choices. This isn't they're much more, let's say, convincing experiments than their online survey, right? But there's experiments when people are asked to make choices between different options, and they show what seem to be reversals, inconsistencies. So there's a sense in which, maybe in a broader sense, we'll talk about revealed preferences, but people will choose an element in one budget set when other elements in that budget set were available, and then in another budget set, they will choose that when they have a different budget set, they will then choose an element that they could have chosen. I'm probably getting this. Oh, I'm trying to think. What's the exact example here? I'll construct it. But anyways, you're given different budget sets. So, oh right. So maybe they chose this in this particular budget set. In this budget set, they choose down here, and then in this budget set, they choose here, right? But they could have chosen this in the first budget set, and yet they chose not to. They chose, and they could have chosen this in the second budget set, and yet they chose this. So there's subtle reversals. People have done this looking at supermarket data, and that's a little bit controversial about whether people have made these violations, but how much opportunity they have to make these violations. And in the Osborne-Rubinstein text, they give sort of series of things to decide between. And if you look at them closely, you'll see that people are, in fact, making at least some reversals. Now, we can question what would be going on there. Would people's preferences be, I mean, what would be some reasons why you might see reversals in a survey like that?
You just got confused. Or
People weren't paying enough attention to it, yeah. But maybe their preferences changed over time. Maybe they got new information, right? So if we're in an environment with new information, it's not really the same good. Okay, so, but we will consider further whether preferences are truly, whether it's reasonable to think preferences are transitive, when we might see violations of that. And we will also look at particular numeric or particular whatever restricted versions of preferences where in fact we do not see transitivity, where we see that violated, where we see what look to be preference reversals. And then you can say, oh, actually those preferences, that seemed like a reasonable set of preferences, yet it violates transitivity. But we're going to need completeness and transitivity in order to establish most of the decision theoretic, microeconomic results about choices. But one distinction I'm making here is right now I'm only talking about preferences. Okay, I did mention choices, right? But the book makes a distinction